tell us C is 0.90, 90%, and N is 10. First thing, N is less than 30, so we got to use the T stuff. Need to have your charts out. I might not be able to find mine. We get to the T chart. Confidence level along the top here. And I about forgot we gotta find what?
X bar.
Or the designated degrees of freedom.
Oh,
Degrees of
minus
freedom.
one.
Freedom.
So it's 9.
So it's 10 minus 1, which is 9.
9. Gotta go.
Make sure you don't forget that. Otherwise it's gonna change your number here. What's our critical value?
1.833.
Anybody else get that? Because I can't see it.
Yeah. Yeah.
Next question.
Number 6.
8. You guys are picking questions from the same
Well, I don't think we have.
column thing.
No, 6 is different.
It's the same as number 8. Like the same kind
Well,
of concept.
I want to say.
That song's stuck in my head
Says find the margin of error, so we're looking for E. Somebody's going to tell me out what was the formula for E on this one.
TC S over the square root of A.
Same as last section, right? TC, we got to do the same thing. We got to find TC, so we got to use the chart.
So 5.
So it's 99. The degrees of freedom is 5.
4.032.
Notice, when your N is small like this, 6,
It's big.
what happens to your TC?
It's big.
It's big, because we're not as confident about stuff in this certain interval. So we put in 4.032. S is 3. N is 6. Do that math for us.
4.938.
That's our E, that's our margin of error. Jenny, you still want 8?
Yes.
Number 8. C is 98, S is 4.7. And N this time is 9. What's our degrees of freedom then?
8.
Same idea. Use the 0.98 and the degrees of freedom. Look up on the chart, figure out what TC is.
2.896.
Is everybody seeing where they're getting all these? And is that right? Because I'm not looking at my chart, so I'm hoping that nobody's telling me wrong.
Then you take 4.7.
4.7 on top,
Square root
square root of 9. Some of these, when it gets easier, or something like this, I wouldn't punch in the square root of 9 on my calculator. What is the square root of 9?
9. 3.
Make it a little easier on yourself if you can do something in your head to punch it in. Less chance that you mess up by punching something wrong in the calculator.
That gives you 4.537.
Does everybody agree with that?
Mhm.
Again, that's our margin of error. So if we found X bar, whatever it is, we would go out this way 4.537, and we would go out this way, 4.537, to make our confidence interval. Next question.
17.
In exercise 17, 18, you're given a sample mean and a sample standard deviation. Assume that the random variable is normally distributed, and use a t-distribution to find the margin of error and construct a 95% confidence interval for the population mean. Interpret the results. If convenient, use technology, so on, so on, so on. So 17, they tell us random sample of 8 people, so our n is 8. The mean commute time to work is 35.5 minutes. That's our X bar, 35.5. And what else they tell us? Sample standard deviation is 7.2. First thing we want to find TC. All they told us C, didn't they? What did they say C was up in the directions? 95, is that right?
Yeah.
Find TC, our DF, our degrees of freedom is what this time? 7. Somebody help me out, look up on the chart. 7 and 0.95.
2.365.
What is it?
What?
Is that right?
2.365.
I was above one. I was at the one.
365.
Yes.
Once we have that, we're going to find E. We find E by taking that number, 2.365 times x over the square root of 8. Somebody do all that math for us. I think when we take the next test, we ought to make it where you can't use your calculators ought to make you use the little red calculator, shouldn't I?
No.
I don't think so. Alright.
6.7076.
Well, rather than use a calculator, you should drop it on the concrete.
You saw that?
7076.
It
Yeah.
scared me, and I looked back and I saw you drop your calculator.
No, it still works.
Wait,
I did drop it.
Is that wrong?
I heard it smack, and I was like,
no, he's probably right, but I don't know.
so I thought I dropped something, so I looked back and see what it was. I was like, pick up the calculator.
You put it all
I have
in
so
one.
much in my hands, buddy.
I was about to ask
You
you.
put it all in one?
No, you don't put it all in one.
Dude, it's probably easier just to do this part first,
And then,
and then hit equals,
I
but
don't know
hit
why I
times
just
that,
checked. I literally used it earlier to do the work.
because otherwise, sometimes the calculator doesn't give you you and the calculator are on the
Is it
same
ever
page.
in like algebra where like these reasons which one like not to drop?
No, I'm still getting the
Yes.
same thing I
so
had the
here's
other way.
with math.
yeah.
I don't know, I don't have a calculator up here, so.
I think I dropped one once.
Let's see. Square root of 8 is somewhere about 2 point something if we divide that into 7, not quite 3.
Do it again, I think, see if you're still giving me the same thing.
I don't know, 6 looks pretty close. I
Well,
can't-
it's a 6, but it's.
6 is right, but like the
Oh,
decimal.
it's the decimal,
Oh,
but,
yeah.
Oh, I got 02, 03.
Oh, I know I get it wrong.
so
I put
it's 6 point what?
6.35. It's 6.020.
203.
Yeah,
We'll go 6.02, that's close.
I put 6.3.
So we have that. Once we have E, when we find our confidence interval, we take X bar minus E on one side. This is for you. Sorry, I'm thinking about what we're doing today and write the wrong thing. And X bar plus E on the other side. So over here we got 35.5 minus 6.02. And on the other side, we got 35.5 plus 6.02. What's that give us?
29.48. And 41.92.
Then the explanation. It said to explain it also. And again, is this the way you have to write it?
Right into print.
Now you could have wrote it with the parentheses with this number right here in the first part and that number in the second part, whatever. The explanation of this is with, what was C, 95% confidence, we can say that you will be between, and I'm not writing both those numbers out, between those two numbers. So the average commute time of the population, we're saying we're 95% confident that the average commute time of the population is between 29.5 minutes and about 41.5 minutes. So somewhere 30 minutes to 45 minutes, somewhere in there. Could we have done all this with the calculator?
Yeah.
Yeah.
I'm not even gonna show you how, because on the quiz,
We wrote it down, didn't we?
I think so.
Yeah, I think we did.
It's like the stat and the zero.
And then you just enter all the
I
things.
don't know, you wanna try it real quick on your calculator before I erase all of it and see if you guys know how to do it?
Yeah.
Might not be a bad idea.
Is it the same one again? The same
Mhm.
problem with.
Is it Z interval room?
It's, not Z interval.
T interval.
T
Yeah.
interval.
You said we have a quiz today too?
You didn't-
T interval,
You didn't see that, it's
stats,
been on the board the whole time.
X bar.
Oh, now I see it. I just read, I thought it was,
You know how to do it?
So, wait,
Wait,
put
yeah.
A as 8, or N is 8, or
Or 7.
Eight.
And then
It'll already do that for
Yep,
us.
it gives us that.
Yep, it'll do the DF for you. It'll find the TC for
I
you.
got loading.
Loading.
29.481 to 41.519.
Yeah.
Got it.
Right on the money.
Other questions?
do 18. Hold on, we're saying
We didn't need to do
We
18.
didn't need to.
Oh, I don't know which one, was there one that's just like it?
You wanna do 18, just do it on your calculators?
Yeah.
Yeah, I need to try that one.
Number 18 says in a random sample of, well, first of all, the directions tells we know C is 0.95, right? So I'm gonna write that up here before I forget. In a random sample of 5 people, so that's N. The mean driving distance to work was 22.2 miles. So that's our X bar, 22.2. And the sample standard deviation was 5.8, so that's our S, 5.8. Plug it into your calculator, see what you come up with. The bad thing with using your calculator, it doesn't tell you your critical values. It doesn't tell you your margin of error. It just tells you the final interval.
So you still have to find out to check it.
You might have to find it to just know the margin of error and stuff like that.
Is it mine?
Oops, not second, it's third.
Wait,
T
right.
interval.
What is it?
Do I do anything else to say?
Give me some homework.
You're in the wrong picture.
No. Oh, I'm in. I'm
You're,
not.
you're in Z10.
I know, I didn't realize that.
Well, if you guys are having this much trouble with it, when I had some new today that's in that same area.
No, that was my fault, I just didn't change it to Z.
Do you want it?
Or to
Sure.
T.
14.998.
Is it T interval?
Yeah.
And to the side, 29.402.
Anybody else get that?
Yeah.
Yeah.
Wait. About to.
Wait. Make sure I put the number.
What
Ray, I don't care about nobody else, that what you got? I don't care about nobody else, is that what you got?
Where did it go?
Alright. The heck with all the rest of them. You're the only one that matters. Other questions?
13.
13. If they were nice, Michael, they might have told you to make sure you read the board.
They'll probably
Michael,
back
make
there.
sure you read the board.
That black one going up there. 14.7 and 22.1, that's our interval. Same idea on this one as the previous section. How do we find the mean?
You kind of go backwards on it.
This is the one we're sort of working backwards. Remember, the mean should be located where if we're looking at this interval. This is why sometimes it helps to
Shouldn't you add them and divide by 2?
add them and divide by 2. That's why sometimes it's better to look at it on a number line because
It should be in the.
it should be in here, right?
Yep.
So 14.7 plus 22.1 divided by 2. If you tell me the answer is 15, wrong.
18.4.
18.4, anybody else get that?
Isaac, you went fast with it.
Does that make sense? Does that look like that's right there halfway in between those two?
Yeah.
And then the other thing we want to find is the margin of error. Remember, the margin of error is, you're saying, all right, from 18.4, that means, how far out this way are we going and how far out that way are we going?
Can't you just subtract them?
So what do you do with these two?
Just subtract them.
Subtract.
Now, again, probably when you're punching in calculator, what do you want to make sure you do with these two numbers?
Separate.
Make sure that the.
Flip them so you don't get a negative.
Put the bigger one first, so you don't get a negative, so I don't have to answer questions about, well, I got a negative answer. Didn't get a negative answer.
Oh, yeah, okay, I did that one.
7.4.
Shoot.
She did
Did
it
you
right
divide
after you
by
said.
2?
Oh, no.
Yeah, I didn't
It's
divide it by 2.
3.7.
Yeah, you divided by 2.
Because I got 7 for first one.
Now, look at what we have. From 18.4, does it make sense to get up to 22.1 that you go up about 4?
Yeah.
To go down, does it make sense that you go down about 4?
Yeah.
Yeah. That's your margin of error. You're saying, all right, right here I got 18.4. I'm going down 3.7. I'm going up 3.7 to get my interval here, my range that I'm saying that our mu falls in. Other questions? Just ready?
Yep.
Instead of finding an interval for mu, for the mean of the population, we're finding the interval for a proportion, which is just a percentage, all right? Remember, population proportion is a percentage, like a percentage of whatever falls in this range or something. Or what percentage, I shouldn't say that, that's not correct. The percentage is, what's the percent chance that if I pick somebody that we're gonna get a success? So if we were looking at the classroom, maybe I better get up and turn off the recording before I say this. If we were looking at our classroom, I better be nice.
Just say it.
No, I gotta think of something else now.
Say it. I'm curious.
We're looking at our classroom and we're trying to figure out the percent of geniuses we have in here. Well, we know it's gonna be 100%. See, I was being nice. So you can conjure up in your mind what I was gonna say before I started,
I've
caught
got,
myself and,
I've got a couple thoughts. And they would have been funny, but.
so what we would be looking at is, what's the chance that I pick a genius out of the classroom? That's what this is gonna do. Oh man, we gotta, dang. Next week, symbols test. I keep forgetting about it, keep forgetting to run it off. But now we got my favorite. Is there another, might be another thing on this one. Yes. P-hat.
Is that actually?
That's the name of it. That little P there with that little thing on it, it's P-hat.
That's so easy to remember though. P-hat. Cause it looks like it's got a little hat.
Now the bad thing is, on the symbols test, you're not allowed to write P-hat.
What?
You gotta tell what it is.
Oh.
It's the proportion of successes in the sample.
What's the proportion of successes? I'm gonna put P-hat and proportions of successes.
Maybe if you guys, you're not all on my nerves for the next few days, and maybe when I give it next week, I'll
We won't see
accept
you
P-hat.
until like what, Tuesday anyway?
So you shouldn't be able to get on my nerves, so you got about 45 minutes to not screw it up. So the population proportion, again, the probability of successes in a single trial of a binomial experiment. Remember, a binomial experiment, two options: success, fail. All right? P is that proportion, that population proportion. P hat is the sample proportion. If you wrote that, if you wrote sample proportion, I would accept that. Sample proportion, that's P hat. You find P hat, and a lot of these you're gonna have to find P hat yourself. You find P hat by taking X, which is the number of successes, divided by N, which is the total number in the sample. Again, we're going to do all that same stuff that we've been doing for the last two sections with P hat. So you're going to find that interval that we're 95% confident that P, not P hat, but P is going to fall in. So it's the same stuff, just instead of using X bar and mu, we're using P and P hat. So that's just saying that for the parameter for a population, it's P. For the sample, it's P hat. So P is the population proportion. P hat is the sample proportion. Same idea as before when we had P before. Q was 1 minus P. Well, Q hat is 1 minus P hat. So just remember, you subtract P hat from 1 to get Q. If P hat stands for the successes, what's Q hat stand for?
Failures.
The failures. So if we think that if P hat ends up being 0.7, 70% success, then Q hat's going to be what percent failures?
30%.
30%. Remember, it's just like having a 100% there.
Wait. For like.
Well, you said it's subtract
1 minus that.
I thought that was just 70.
Okay.
Well, if we were writing it as a percentage, it'd be 70%, right? So if we change it to a decimal,
Okay.
And if we were writing it as a percentage, we'd have to change this 1 into 100%. Which I don't even want to talk about because you guys like writing percentages too much. We figured that out on that last test. On this example, in a survey of 1,219, make sure you got your calculators out so you can help me. 1,219 adults. That's our N. 354 said their favorite sport to watch was football. That's a success, so that's our X. Find the point of estimate, so we're finding the P hat for the population proportion of U.S. adults who say their favorite sport is football. All you got to do here, to find P hat, you just use that little formula that you just had a couple slides ago, and it's X divided by N. So 354 divided by 1219. Somebody help me out.
0.2904.
We'll just round it off about there. So about what percentage, I shouldn't even say that, about what percentage of people say football is their favorite sport?
29%.
About 29%. Write your answers this way, don't change the percents every time, unless they ask you to change it to a percent. A C confidence interval for the population proportion P. Again, notice here, it's P, just like before it was mu in the middle there when we're writing this confidence interval. You're doing the same thing, P hat minus the margin of error, P hat plus the margin of error. This formula is a little different. To find your margin of error, margin of error. So it's a little different. But it's the same idea. This time, notice, what are we using? T-scores or Z-scores? Z-scores. So instead of using this chart, now we're going back and using this little chart right here, or if it's not on that little chart, the first 2 pages, which I think most of them are on the little chart. Again, most of the time we'll do confidence levels that are 80, 90, 95, 99. Won't usually do any of the others. So Z stuff, you're using the chart on the front page of the packet. P stuff, or T stuff, you're using the chart. Sorry. There's one more thing there. Using the chart inside the T chart, wherever it's in your packet. So if we go back to my example, what this interval is telling us. On my example, I said it's 100% chance that we're going to pick a genius in the classroom if I pick one of you at random. When we make our interval, we go by whatever. If we want to be 99% confident, then we use that 99% or 0.99. And we're going to make our interval, and we're going to say it's probably not exactly 100, but we're 99% confident that it falls in this certain range, in this interval. Whatever that interval comes out to be, if we found the margin of error and plugged into this formula here. Way to do this. And I'll tell you what to write down on this. Number one, just write find N and X. Number 2, find that, your P hat. Number 3, and just like before, does anybody remember doing this before? where we had to take n times p and make sure it was bigger than 5, and q times p and make sure it was bigger than 5. And I always forget to do it because I always know if it's bigger or if it's not. Do you really have to multiply both of them times n to see which one, if it's bigger? Do the smaller one. Just do the smaller one. If the smaller one's bigger, then the bigger one's going to have to be bigger. Who knows? I might be a jerk next time and throw one of those in on the test. And then
We
when,
have a test next time?
when everybody, whatever the next test is, then when everybody answers it, and I'll say, nope, you couldn't do this problem. There wasn't any answer to it. And Lily will be mad at me. So sort of make sure you check it. Most of the time,
I would mind myself.
most of the time it's going to be bigger than that. Next one, number 4. On this one I put use the little table. That little table that's on that front packet, or the front of the packet. Number 5, you got to find your margin of error. And number 6, find your interval. That's all the steps to doing these, just like the other 2 sections that we've done in this chapter. Again, the only thing that's really any different is that margin of error formula. A little harder. Because the way you have to do it, when you punch it in your calculator, you got to be really, really careful, or you're going to get the wrong answer.
Does it work better?
If we're using Z, what's that tell us about our samples? If we're using Z, what do we know about our sample sizes?
That they're not.
Should be
Oh, it's 30 and up.
30 or more, right? If we're using Z. There's other things that could happen, but a lot of times that's what it's going to be. On the calculator, what you can punch in, this is what I was talking about. If you're punching, bad thing with the calculator is now you got to know which one you're doing. If you were having trouble telling the difference between the Z intervals and the T intervals, then when we throw this in, it's going to make it even worse. I think L is the actual letter on the calculator. I think it just says prop Z int. I think L is the what you go down to, like it goes A, B, C, D, or something. No, I'm wrong. There is no L in here.
It's just more probably.
Maybe that's supposed to be a 1. Yeah, change this.
Is it?
I think it's 1. We'll find out here in a minute. I wonder how it got to be an L. Is L close to 1 on the,
No.
not anywhere close to it?
There's no L.
No, not on the calculator, on
Oh.
the
On the
keyboard.
keyboard?
On the keyboard.
No.
They're not close either, though.
I don't know actually. I
It's
couldn't
down
see.
here.
L's down here.
L's is
One's
towards the
like
bottom.
up here, is it?
Where you have your fingers on the bars, it should.
We're
I
talking
don't
about on
know
the
either.
keyboard, Jay.
I don't have my
This
fingers.
one here.
We're talking about on the
Yeah.
keyboard.
Because this one's semicolon and this one's
No,
no.
No,
H,
on
I,
the
wait,
keyboard.
the
One's
H,
like
I-
a
Like
computer.
a L.
Like a computer.
Kel.
Kel.
K and an L,
Oh,
yes,
yeah.
it's K and an
Then
L.
one's up here.
Good idea.
All right, back to this problem here. It says in the survey, the same problem, construct a 95% confidence interval. First of all, we know that P hat, we already figured it out, it was 0.29. When we figured it out before, and all you did there was you took, this is N, this is X, and you divided those two and got 0.29. We want to construct a 95% confidence interval. We could do this using the long way like we've been doing, or we could try to use our calculator. Let's try to use our calculator on this one because I want to see if that is supposed to be a 1. So if we go down to 1 prop Z interval, it asks us to put in X, N, oh, we didn't even have to find the P hat because it's doing the P hat for us.
I thought we weren't going to see.
Am I on the wrong one?
I thought it was prop Z.
Right, that's where I went.
But is it 1 or 2?
1.
Huh?
We were just, stay off your daggone wrist watch there and focus. That's what we just, no, that's what we said for the last 5 minutes. Hey, Ebersole had L up there and he doesn't know what it means. And he thinks it's 1.
I saw, you said Z interval, and that's not how I've been reading it in my head. And so, I was reading prop Z, and I was like, that's dumb.
Are you guys still listening to her? So we type in 354. Dang, going it. Now I typed in the wrong thing. 1219 and 0.95. Hit calculate. Notice this time it does help. What's it tell you P hat is? What's it tell you P hat is there?
I'm done. 0.29 minutes extended. So like
Got more?
401.
What's it doing? Yep.
Calculate, right?
Yeah, go down to calculate. Oh, hold on, go back.
Oh, I see.
I don't know what you punched in. Lily, are you mad at me? I shouldn't have
I
made
got
that.
P hat,
That's
it's the
okay.
same.
This one?
No, it's not. I shouldn't have made
This
that.
one?
But it did annoy me that I just said that.
Yeah. That's right. Yeah, oh, that's right. Mine gives me error to me.
Oh my gosh.
Trade me.
Kid's ACL's blown out. Me either.
You put in 219, Mike, and not 1219.
Swim.
Oh, that's probably why.
Yeah, because that's more than 100% then, and they won't understand it.
I thought you said 219. Yeah.
So when you do this, it gives you 0.26. So our interval is about 0.26. I'm not writing it all out. 0.26 and 0.32. So we're saying we don't think that 29% of the population actually are going to say that football is their favorite sport, but we're 95% sure that the percentage is actually going to be between 26% and 32%. That's what we're saying there. And they worked it all out. Longhand here. See if they got the same thing. 0.265. There's a little different in ours. 0.265.
If you round up though, you get that. It's
Oh yeah, I can see the 9 behind the 4. Yeah. Or I would have rounded it up anyway. So our confidence interval looks like that. So the explanation again, with 95% confidence, you can say that the population, or the proportion of adults who say that football is their favorite sport is going to be between 26.5% and 31.5%.
It's probably more now, it's freaking baseball.
All right, write that down. To find, we did this on one of the others too. To find the minimum number of people or whatever we need in our sample to make our numbers make sense, we use this formula. Again, it's not really a hard formula. You just, when you punch it into your calculator, you got to do it a part at a time, or it's probably going to mess up. If you figure out how to do it on your calculator by punching it all in at once, that's fine. Don't try to explain it to me though, because I'm not going to care. If you know how to do it, you do it. But I guarantee that out of all of you, not everybody's going to be able to punch it all in, because somebody's going to punch it in wrong if you try to punch it all in at once. Isaac, are any of those freshmen any good at baseball?
No. Cooper Smith's not bad. He's pretty good.
He's one of the few that I thought maybe looked like he might be all right. The rest of them, I thought,
Yeah, it's more.
you play baseball?
Isaac, who is your
Next.
guys' catcher for real?
Cooper Smith.
Okay.
After
not-
after like my class graduates, we're gonna not very good, because there's only like a couple juniors that are decent and good. And after that, I guess, and there's like 2 sophomores. Then it's gonna be.
Because I was gonna say, is he your catcher for real?
Yeah, he's actually pretty good.
No, not Cooper, the one that was catching Wyatt. What's his name?
No, Fletcher.
Yeah. He missed every ball. And then he can't make a throwback to you.
Don't say
What's
names.
happening?
Yeah, a junior almost hit Derek in the
Yeah,
head.
a junior.
And I can jump, and I couldn't even get up to catch that ball.
It was flying everywhere.
The other catcher that you just mentioned there, I said something to him yesterday, because he said he went down to block a ball, and it caught me in the leg. I said, you got shin guards on. Well, my sons are catchers, I know how you're supposed to catch. He goes, well, when I went down, I turned so I could block it. I said, no,
Just take it.
you don't ever turn.
Why was
Why would you turn?
Or anything you
why
drop
was
your
that
knees in
kid
so you
catching
have...
you, Isaac?
Well, we were just
Messing
throwing.
around?
See, Ben, the junior thinks he throws like 84, but you don't know where that 84 is going to go. And he thinks he's going to Vanderbilt right now. So he's gunning it, and I'm like, dude, chill out. First off, I can't see the ball because in the gym, they got that the brick wall, and I can't see the ball because the ball's dirty, and he's winging it at me. I'm like, Ben, chill out, dude.
My son's always complaining inside anything catching.
It takes me off. And plus, kids can't throw, so you got balls flying at you, and it just drives me nuts.
A girl on our team got hit in the face by 3 balls the other day because she was passing. One came from this side with 2 freshmen, and one came from this side with 2
Guys,
freshmen.
I hate...
And
oh
she
my
just
gosh.
put her glove up and prayed, and then she had a big red
Usually,
circle.
Moose kicks out all like the JV team. Once we get like started in like a week or 2, he'll make them go to middle
Well,
school.
yeah, this is a
They
Jay
don't
always
practice with the JV.
They always practice separate, but like first 2
My
weeks.
middle
a year.
son is up at EMU, and he's got a couple of catchers, and they all think that they're great. You know, they came from other schools. They think like one of them was at Purdue, and one of them was here, and one of them, you know, they were all over at big schools and didn't make it, and so they came to
To a small
Eastern. And they're inside their big practice bubble, that, you know, one of those
Yeah.
big stupid dome things that every school builds for practice for football and baseball and everything. And he said, Dad, I just tell him finally after a while, I say, you know what? This is supposed to be a bullpen session. You're not supposed to be trying to throw 95 every single time. You can't see in here. I'm not standing here catching. if you're just gonna see how hard you can throw all the time.
It drives me nuts.
It's ridiculous.
And people do it in warm-ups too, like, well, like, they'll be gunning it across the gym. I'm like, dude, chill out.
Yeah. Alright, so again, this is to give you the number that you need in your sample to make sure that your numbers make sense. So, if you're looking for this, you gotta know what P hat is, you gotta know what Q hat is, you gotta know what your margin of error is, and you have to know what your critical value is. Couple other things on here. If, and this right here is very, very important, because most of the time, we won't know if we're just starting to do this, we will not know what P hat or Q hat is. Alright, so if we're going out today and we're going to take a sample of something, we're not going to know what P hat and Q hat is because we haven't done anything yet. So if we don't know what P hat and Q hat are, we just assume that they're 50% each, 0.5 each. So if you don't know P hat and Q hat, and you're trying to find how many people you need to go out and put in your sample, or how many whatever you need to put in your sample, use 0.5 for both P hat and Q hat. Does that make sense? Now, are we just going to put 0.5 in for P hat every time?
No.
No. This is just, you're starting something out, you can't know what the percentage is. If I say, all right, I want to know the percentage of National Trail students who own a rabbit, and I have no idea. Well, I could go out and sample 3 people, and all 3 of them have rabbits. So I say, oh, well then 100% of all National Trail people have rabbits.
Is that how, like, politics things work? They ask, like, certain groups
Right.
to make it sound better for whatever they're trying to do.
Well, they're not supposed to do that, but sometimes they'll say, and you'll hear them, and they'll say, oh, we were in such and such a place, and we asked all the people exiting this place what their ideas are.
That's like going to, like, Preble County and asking if you vote
Really?
Republican or Democrat.
Right, so it'd be like if I came down to the lunchroom and I stopped at one table full of, just one set of friends. And I asked them, okay, what do you think, what do you think, what do you think? Well, I'm getting the same opinion out of all of them.
Yeah.
So that happens a lot.
Unless it's football.
Did you hear Mr. Bertzel's coaching us now too? He's helping.
Is
He's
he?
back at
He's
church.
back?
Yeah.
And tell him. You guys?
Yeah.
Yeah, he's a good coach.
He was crap.
He's a good percent.
You're running a political campaign in which to estimate the 95% confidence, the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Find the minimum sample size you need if there is no preliminary estimate. So, in other words, we're going to have to use P hat is 0.5 and Q hat is 0.5. Because we don't have any preliminary numbers. We don't know who's going to vote for this person and who's not going to vote for him. So if we do this, we got our confidence level, 95. That's 1.96 if we look it up on the chart. Our margin of error, let's go back to this to make sure you understand this. Make sure you understand, they say you want to be within 3%. That's your margin of error. So you're saying, whatever you pick, whatever number you get here, you're saying it's within 3% that way or 3% that way. And Isaac, what you just said, that's what they do for these political things.
Is that why it always says like plus or minus?
It says plus or minus
5%
something,
or
right?
whatever.
And some of them you'll see them and they'll say like plus or minus 15%, and I'm like, really?
So it could be at 50 and it's going all the way down to 35 or 65.
Right. Why even do something if you're going to have a margin of error that's that big? That makes no sense. Why?
It's like saying Trail's going to win state this year in baseball, but we got 99% plus or minus.
Right.
We got a chance. Let's go. Everybody has a chance. Yeah. That's the whole point.
So we do all this, we plug in here, 0.5, 0.5. Our ZC is that, our margin of error is 0.03. Do me a favor and grab your calculator, because when you do this, you're going to have to make sure that you can punch this in and not mess it up. So try to punch that in and see if you're getting the same number they get. I'm not going to tell you how to punch it in. I just want to see you try to see if you can get the answer. And if you can get the answer that they get, then you're doing it right. And I'm not going to say a word about how to put it in.
I use the first one real quick.
No, there's not.
There's not an
Jenna.
I know.
Everybody figure out how to get it?
He did.
Still not right on?
Ooh.
All right, if you're getting it and you know how to do it, and you're sure, put your fingers in your ears. Those of you who aren't getting it, this is the way I would do it.
I got the same thing twice.
The way I would do it, what's in parentheses, I punch that in. 1.96 divided by 0.03. It equals. So I get this number, all right? Just leave that number on your calculator.
Oh, I got the square.
Then hit the squared button and hit equals.
Okay.
Then take that number, so now we've got all of this. Take that number and multiply it by 0.5 and 0.5. So just hit times 0.5 times 0.5.
I got it.
I didn't get it.
So make sure you're not punching it in wrong. Easy to mess it up. When we're doing this, again, we're finding n. So you always want to round this up. You're always going to round up, so that'd be 1068, because we're not going to have 0.11 of a person if we're talking about voters. So you're always going to round it up. Now, I don't know, maybe when Michael's running for political office, he'll have 0.11 of voters. He'll have those people who have been dead for a while that sort of decayed away, and that's like 0.11 of a person.
That's all I got.
Holder of hand is left, that's it.
Yeah.
There is that one hand of it.
So on this, if we're trying to make this, this one 913, we round that up to 914 voters. The assignments on page 332, only a couple more assignments for this 9 weeks. So if you're not happy with your grade, got a couple more assignments to get picked up. This quiz will be one of them.
I'll tell you what's funny talking about baseball. When my dad starts talking about when they lost like in the regionals or whatever,
Yeah.
every single time he goes,